Hey there, hi there, ho there. Welcome to Unit 11, Groundwater. We spent some time last unit talking about surface water. Now we're going to talk about water below ground. This is the water that most of us utilize, that we drink, that we clean, that we bathe with, is typically groundwater. Most of the U.S., I'd wager probably most of the world utilizes groundwater. So let's talk about it, shall we? Thinking back to last unit, this was introduced. But fresh water only makes up 2.5% of the Earth's water. Of that 2.5%, 30.1% of it is groundwater. So 30.1% of 2.5% is actually about 0.75%. Total Earth's water is groundwater. All right, so if we think about all of the Earth's water, 0.75% of that is groundwater. And the surface water takes up only about 0.03% of the total water amount of water on Earth once you do all the mathematics. So there's way more groundwater than surface water. So 25 times more, in fact, groundwater than there is surface water. So that's why we're going to utilize it and rely on it so much more. So just some information on groundwater, some terms that will help kind of understand what's about to come. So when I talk about groundwater, groundwater is any subsurface water, so below surface, contained in pore spaces in soil and bedrock. Groundwater, there's not just big giant holes in the earth filled with water. That's not groundwater. That does exist in some cases in smaller instances. Don't get me wrong, but when we're talking about groundwater, it's not like there's just a big hole underneath Phoenix filled with water. That's not the case. It's actually water in between every little grain of dirt, in between every little rock and pebble. That's what groundwater is. It's kind of in between those pore spaces in soil and bedrock. Groundwater isn't necessarily a flat level of water below ground. It does follow the contours of the land. When we're talking about groundwater and accessing it, a large body of groundwater is called an aquifer. So underneath, for instance, Phoenix, there is a large underground aquifer. That's what we tap into to get our groundwater. And then another term you'll hear in just a second is the water table. That's the boundary between dry rocks and dirt and saturated with water underground rocks and dirt. So, if you dig down in the ground, it's going to be dry, but at some point when you hit water, you hit the water table. All right, let's put all that together. So, when we're talking about, again, ground water, we're talking about the saturated zone where water is really in between the pieces of dirt, rock, soil, whatever it may be, as ever small the space may be. That's groundwater. It's water located in these pore spaces, not just an open pit. The water table, again, is the boundary between where there's dry ground and then wet saturated ground. So again, this is looking at just a little slice of this terrain here. So as rain precipitation falls onto this area, it filters through until it hits the water table. Now, again, this area has no saturation, but water does percolate through it down to the water table. Now, if it's a particularly wet season, the water table may be up here. Maybe a little bit drier season, the water table might be down here. Just depends on how much precipitation we get, and that's different around the world. As you see here, this water table follows the contours of the land to a point. It's not equally below ground at all points, but it does follow the contours of the land. That's kind of good to know. So again, looking at the water table, again, it's really just the groundwater is just that water in between the pores and in the spaces between rocks, dirt, soil, any little particle underground. It's not just a big open cavern. So there are a few large aquifer regions that are managed by the state. We are in the Phoenix aquifer here, but different locations have some different groundwater that they tap into. Flagstaff is up here, and they can't really utilize groundwater because the groundwater in Flagstaff is so deep. It's just almost impossible. It's not cost efficient to drill all the way down there to get the water. So they use more surface water. But you can see Phoenix, Casa Grande, Tucson, Prescott, we're really utilizing that groundwater. So here's the Phoenix area aquifer. Again, it's under the whole Phoenix metro area. If it wasn't for this water, modern day Phoenix would not be here. There's not enough surface water to sustain that. And Avondale, right in this location, we're at Estrella Mountain Community College. So we're in the kind of the heart of this aquifer. So I'm specifically going to focus on Avondale. That's where Estrella Mountain Community College is. So we're going to look at Avondale's water portfolio. So the city delivers drinking water to its customers from groundwater production wells located throughout the city. So throughout the city, there's pumping sites. You might even have one in your neighborhood. So this is where they pump out water, kind of just filter it out really quick. But other than that, it's pretty much good to go. I know when you think, ew, water from the ground, it's going to be dirty and ew, gross. No, it's actually pretty clean. As precipitation lands on the earth and it filters down into the aquifer, that water, as it filters through the ground acts like a natural filter. It actually cleans it. So groundwater is actually much cleaner than any surface water. Fun fact. So, since we're taking out water from below ground, any water we use, we need to put back in. It's called recharging the aquifer. That's something we do, as well as all cities in this area do. Since we are low on water, we live in a desert, we can't just take. We have to put back in to hopefully keep that cycle going. But as more people move to Phoenix, as the population of the Phoenix metro area is growing, the more we use, the more that underground aquifer is going to shrink. The further that water table is going to go below ground. So what we've had to do now is divert some surface water to recharge areas so water can soak back into the ground. We do that via the Central Arizona Project, CAP or CAP. So 31% of Avondale's water that we pull from the ground came from the Central Arizona Project. More on that in just a second. 37% of the water we pull out of the ground was originally coming from the Salt River Project, SRP, putting water into the ground, filtering back, and we suck it back out. 32% of the water that we pull back out of the ground is reclaimed or effluent water. This is water, so after we flush the toilet, wash our clothes, whatever, all of that water from our house or businesses goes to Avondale's water treatment facility. They filter out all the pee, the poo, all the toilet paper and such, and then they dump that water, which is clean, back into recharge areas that filter back down into the ground, recharging the groundwater. Don't think that's weird because, what, actually, a side note, the water coming straight out of a wastewater treatment plant, even before it goes in ground and filtered, that water is actually much cleaner than any surface water. I would rather take a sip of treated wastewater leaving the plant than take a sip of any river around here. If you've ever been down to Tres Rios, any lakes around here, I'd rather drink wastewater, treated wastewater. Fun fact, it's much cleaner. So, the Central Arizona Project, what it does, it diverts water from the Colorado River into the central portions of Arizona, even down south into Tucson. Some of these circled areas are recharge areas. This is areas where kind of they recharge the aquifers and then just kind of divert some of that water, kind of dump it into recharge areas where it soaks into the ground down into the aquifer. So here is Phoenix. Avondale is right around here. So just north of us is where some of these recharge locations up in like Surprise, Glendale to recharge that aquifer underneath Phoenix. So 30+% of Avondale's water comes from here, soaking into the ground. We suck it back out. I think 37% of our water comes from the Salt River Project. This is where the Salt River is diverted into different canals. You've seen some of these canals. You maybe walked or hiked or ran or, rode your bike near some canals. Don't drink canal water. That's gross. But that water, we don't use it directly. Again, we soak it into the ground, into recharge areas, goes into the groundwater, and then we suck out that clean groundwater. Some farms do directly utilize canal water, but canal water is pretty gross. Don't. Ew. Ew, ew, ew. We also have something pretty interesting here in Avondale, and it's the Crystal Garden Wetlands. This is a project designed to be not only an amenity for the community and the houses here, but also a source of drinking water or helping to clean drinking water. So in this area, fishing, you can go fishing here. It's catch and release. There are walking paths around all of these different ponds that you see. This is near 107th Avenue in Thomas, over by Westview High School or that new West Point High School. Waterfowl migration, so a lot of ducks and geese use this as they migrate. The fish in there, because it is catch and release, provide specific functions for treating water to controlling algae. So the fish are actually part of the water treatment facility. So this is kind of some images of that area. The plants help to filter this water. The fish in there help to filter the water. And from above, you can kind of see it. There are some parts, actually no, not in this area. You can't really like boat out in there, but you can see some walking paths through here. So in this area, it's 72 acres of treatment cells. So water from SRP and CAP canals is diverted here, and they kind of flow between all of those different ponds. And as they flow from one pond to the next, they're getting further. That water is getting further and further and further treated before it makes its way to a recharge area for it to soak back in the ground. So it's like a natural way to help clean any of that dirty surface canal water before it goes in the ground, kind of just helping it out. So it's passing through all those treatment cells, eventually making its way to the Agua Fria River, or river, because there's no water in it anymore. We've diverted all of that water. So another way you can see that we're using too much water here. The Agua Fria River through Avondale, there is no river. Homeless people live down there. There's no water. And anyway, we take this this water and we eventually, after it leaves all those ponds, we pipe it to a recharge area in the Agua Fria River, right by Friendship Park, where it can soak back into the ground. Every day, this area, the Crystal Gardens, receives about 5 million gallons of water per day, and it's all naturally filtered again before it makes its way into the recharge area. So here is the Crystal Gardens. Westview would be kind of off the screen up here. The new West Point High School's here. So after it kind of filters through all of these, it kind of travels in an underground pipe, and it's dumped in this recharge area. You can see Friendship Park if you ever played soccer or softball there, or have gone to the dog park or whatever. That's right. That's south of McDowell. The recharge area is just north of McDowell, right along the Agua Fria River, of which there's no water in said river. All right, let's pause there. Let me give you a part of the super secret code. It is the number 1. All right, you got me, the number 1. One more time, number 1. But we'll pause here. When we come back, we'll talk about an issue with utilizing all of this groundwater called subsidence. See you in a minute.